Good afternoon, all of you. Welcome to this session on Windows 7 Performance Enhancements. All right. Let's get started. My name is Ranjana Jain. I work as an IT Pro Evangelist with Microsoft India. In my role as an IT Pro Evangelist, I specialize in the Windows desktop and server environments, and mostly the security products of Windows, where my role is to evangelize or to talk about the newest and the upcoming technologies from Microsoft, the products that are about to be launched by Microsoft in the IT Pro space, especially the Windows client operating systems and the server operating systems. So, welcome to this session today on Windows 7 Performance Enhancements. I hope you've been attending the other webcasts in this series that we've been doing earlier and are going to do from here on. Alright, so to get started with, all of you must be seeing a particular poll page on your live meeting window, and many of you responded to that also. So once again, I put up a poll page which talks about how many of you have tried Windows 7 yet. Have you downloaded the beta of Windows 7 and now the RC? And have you been working on Windows 7 RC or not? Right? I need you to respond to this particular poll with either yes or no. If you've tried Windows 7 beta or RC, I would like you to click upon yes. And if you haven't tried it, and you still have Windows XP or Windows Vista, I would like you to click no. I can still see only 2 of the participants responding to the poll. If there are any technical problems with the live meeting, kindly put that up on the Q&A page. Okay, it seems it is. Alright, the poll is open now, and you should be able to click upon it. Alright. I see that 50-50 of you have tried Windows 7 yet. And what similar percentage has not tried Windows 7 yet. I'm going to ask another important question over here. All right. I would not like you to respond to this particular poll. All right. So I see most of you are the right audience over here. Most of you are the administrator of Windows systems. I guess you might be the administrator of client operating systems as well as the server operating systems. So in many environments, you might be administering Windows Server 2003, 2003 R2 or 2008. Or some of you might have tried Windows Server 2008 R2 as well. And in the client environment, you might be administering Windows XP, XP2, Windows Vista, many of you, right? And trying the new Windows 7. All right. So let's get started with our discussion on Windows 7 performance enhancements. And probably at the end of the discussion, I'm sure most of you who haven't tried Windows 7 yet would be keen to try Windows 7 and see how much better Windows 7 performs than the earlier operating systems of Windows. All right. So getting started with this discussion now, I'll move my focus to my presentation. All right. So this is all the API release data. The performance of our operating system would depend mostly upon your configuration you're running on. You're going to focus on things that affect hundreds of millions of people today. So we see what we have worked on, what are the efforts Microsoft has put in, and in what features. And our basic goal has been to improve the responsiveness. The responsiveness of the operating system, as we heard from lots and lots of our customers about Windows Vista, that a number of new features have been packed up into Windows Vista, but besides enjoying the goodness of those features, performance and responsiveness of the system did go down, and it went down to a great extent, so as it really was an obstruction in the adoption of Windows 7 by many of our customers and our partners. So one of the major investments that we've put into the improvements in Windows 7 is working on the responsiveness on this particular client operating system. All right. So moving ahead in our discussion. So we've been focusing on what the users and our telemetry systems have told us. We've been focusing on the user's responsiveness. So in the perception that, it feels faster, it feels better, it feels, more fun to work with. So one thing that we've done with this release of OS is that we've tried to make it so that it is it has a very small footprint on the system. It takes much less memory, much less disk space on the system. So we take out a lot of CPU cycles, reduce the amount of memory they use. So I want to drill down into some of these features that we've introduced in Windows 7. We're also going to build a guidance around if you are building a machine, or if you're thinking of building a machine with Windows 7, if you're carrying a workload, how do you appropriately size that particular machine to carry that workload? So another thing I'm going to talk about is the real-world telemetry. That means our feedback systems and the testing of the system that's carried out in our customer and partner space. The telemetry data has been particularly useful in guiding us to what things to focus on, what features to focus on. Millions of people have used the beta and millions have downloaded and used the RC also. And many of you might have done that and given feedback to Microsoft as to what would you want for Microsoft to work on. So we've got tremendous feedback on that particular platform. So one of the very, very common and the most demanded scenarios in which Microsoft has put lots and lots of investment is improving the transition, the on-off time of the system. So we can divide actually transitions into three types of transitions. One is the cold boot, when the system is booting from the hard disk after a shutdown has happened and we are moving the system into an up state from a shutdown state. The other kind of transition that may happen is when you're resuming your system from sleep or from standby, or the third kind where you may be resuming your system from hibernate mode to a normal working mode. So what are the kinds of investments that we have done in the on-off transitions? Now here's a comparison of a set of machines. The blue bars here show the Vista SP1, and the greenish bars they actually show Windows 7 clean install. Straight out of the box, no configuration change. So what you can see over here, the story is pretty good. We've actually, what we've done is we've looked very much into the boot process of the operating system. We have made the hardware initialization parallel. So we've enumerated the hardware IDs as much as we can so as to initialize them in parallel. So we've looked at the CPU, turned a whole bunch of services into triggered start services. So this is a new concept in Windows 7. If you are a developer or an ISV, you have to think about these services that get initialized at the startup. And at the OS startup, the OS will try to bring all these services up at startup, and that would naturally, you'll have to pay tax at the boot time. So what happens with trigger start is based upon some system events. Some devices plugged in, some kind of system event happens which can fire up the particular service as necessary. So it is not necessary for all persons to get started or have a have a startup type of startup as the operating system mode. Automatic type of startup may not be required. So when you're developing applications, when you're developing services, as developers in ISVs, one of the greatest demand will be to allow a service to be a triggered start service in case it is only required at certain points of time. And some of the things that have gone here, the big parts of boot are also the graphics drivers. So the graphic drivers, the initialization is improved. From the post-boot perspective, after you've logged on, for those who are using folder redirection, we now made it to happen asynchronously. So with asynchronous folder synchronization, it doesn't block you from getting to work for your desktop. So from a user perspective, especially if you're on a wide area network, it basically means that you will get your desktop a lot quicker than what you would have got in the past. So now there is another point on the slide right at the bottom. A lot of people go away and actually do this comparison for how quickly a machine boots up. Now you can measure a machine's real boot time if you've booted it at least 5 times. So what happens is if you take that machine and boot it up, that machine basically learns with a prefetcher. So as you keep on working with the machine, the prefetcher learns the way you work, the applications that you're most likely to open. It learns of the boot plan. It learns over a period of time how to basically calibrate that boot and when to load different pages and points onto the disk and put them back into the memory. You can see about 20 or so seconds differences from putting it to hardware platform to running it on again and again. So we did a lot of work in the background process to make the machine learn how a particular user works and works running on a machine. So this is the story of a clean boot. So the way you install Windows 7 on your PC, the first time you boot it, it takes a particular amount of milliseconds. You boot it the second time, boot it the third time, and you keep on working upon your system. Now, that is when your prefetcher learns the kinds of applications you're going to open up and the user logs on and tries to prefetch those application pages into the memory so as to make sure that your application starts faster and your boot time is increased. So you will see over a period of time your boot time becomes faster, the way you work on your desktop, the amount it takes for you to from the system boot to work on your desktop becomes shorter and shorter. So this is what we've done with the third-party software. So here you see a bit of dramatically different picture. So we loaded some games over here. Now key command is to know and be aware of the stuff that you're loading on the machine. Especially if you're imaging machines for the IIT and you're going to put those images on hundreds of machines. So you must be aware of what you're putting onto the machine because it will have a high impact on how much time your machine takes to boot up, how much time does it take for the user to boot from the boot up of the machine to be really active on the desktop. So that is a very, very dramatic impact in terms of the software. The extra drivers that you load, the applications, they started up at the beginning, etc. So, sorry. Now, you have the user from the point they log in to the domain policies, all those things you need to keep in mind as to what all the entire process the user will go through, the user policies, domain policies, OU policies, desktop policies, local security policies, and the applications that you require to be started and loaded before user logs on. So you have to keep all those things in mind before you load the software onto the operating system. All that will have a great impact on how quickly a user gets onto his desktop. So what we did here is we took Vista SP1 images and upgraded those images to Windows 7, and we saw the changes that it took right from upgrading the Windows Vista SP1 machine to Windows 7. So you need to focus on what you're putting on the machine because that can dramatically affect the boot time in a nutshell. Hibernating and sleeping. These are the other transitions that happen besides switching on your machine right from the time it was shut down. So we've changed these things. We've changed hibernating and made it a lot more careful in terms of which pages we write down. Earlier we used to write a lot of pages, lot more pages when the user's machine used to hibernate. We also used to write them synchronously in very, very little chunks. So we don't do that anymore. What we do now is that we come together large sets of data and write the disk as hard as we can in asynchronously while we are processing the next set of pages we need to write down. So this asynchronous processing is the large chunks of data sets all by themselves really improves the time it takes for a machine to go into hibernation and to wake up from hibernation, because the read time is also faster. The other thing we do during this transition is we bump up the power seats. We push that process to its highest frequency so that we can get this job done as quickly as possible. We are seeing very, very good results from a hibernate standpoint. Again, hibernate is going to depend upon the memory you have on the machine as well. So it's a function dependent upon how much memory you have, how much work is going on, and the disk speed that is there on your system. So one of the key things that affects hibernate and resuming from standby is also the applications. And in time, how many applications are you running at that time? And if you put your system into a hibernation mode where a number of applications are running, obviously you're going to increase the number of pages that you're going to write into the memory. And it's also going to take a lot of time for you to come back from hibernation to the active state, because the same pages that were written on the machine are also going to be loaded back up into the memory before you can get active onto that particular machine back again. So how many of you seen this shutdown panel? Have anyone of you seen this particular panel? So I require you to answer this, alright? Most of you have not seen this. Now I get the response of 50% if you've seen this while shutting down. Obviously those who have been working with Windows 7 might have seen this coming up whenever you try to shut down your machine. Alright, this is a good response. I see enough number of participants here have seen this particular panel while working or shutting down their machines in Windows 7. Now what does this mean? Just sorry. Alright. So what does this mean? Think of it. It's actually a good thing. It's not a bad thing. So, sorry. So this is one of the things that happened through the feedback, through telemetry. What we found in the feedback was really scary. We found that there was a big subset of people or a particular session that was being shut down in a dirty way. In the sense that there was a large portion of people that we found used to be so frustrated with the shutdown process that they kept their power key pressed down to shut down the machine, and that was the way they shut down the machine. Think of it. So we thought, okay, to handle these kind of people, we can do probably a little bit better job than this. So what we did was, we've given you a big 4 shutdown button over here. So this is a virtual software way of holding down the power key button. But we did it in a way that you don't kill the operating system after repeatedly doing this, which might happen otherwise if you were doing a dirty shutdown again and again. So that tasklet up there is also there. Basically what happens now is any application, as soon as the user triggers a shutdown, we give it 3 seconds. So we give all applications to get out of the way if they hang. Now we give all of them 3 seconds, and if they hang around, They pop up in the list, and the user has the way of doing away with that application. After 3 seconds, we let the user handle the application and deal with the application whatever way he wants to. So, and he can go back to the application or bang it down and say, get right of the way over here. He can cancel it out and go to sleeping if they don't want to do that. And this list will become smaller and smaller as other applications finish up, of course. So the other thing we've done and surprised quite a few people with that as well is that we've changed the service timeout interval as well. So that default service timeout is now 12 seconds by default in now Windows 7 client operating system. So they've got 12 seconds to get out of the way before they get really aggressive with them and forcefully shutting those particular services down. So the other thing to look out here is that if you're building images, if you're tuning PCs, there's going to be a pop-up in the event log which is going to give a detailed information about the services that were blocking your shutdown. And they're going to give information about why did they block the shutdown for, what did they block the shutdown for. So if you're tuning and optimizing a machine, it is a place to look for what kind of applications are really blocking or what kind of services are taking a long time to shut down, so as it is slowing up the shutdown process of the system. So you can optimize that particular process or that particular application or service. So, okay, responsiveness. Now, this is what we've really been working on. This is what is our target with Windows 7 operating system. Now, I don't have a slide for this, but I want to talk about this as well. Now, very early on in the Windows 7 development life cycle, Windows has been around for a long time, maybe around 20 years from now, right? So there's some component like the GDI component, GDI32.dll, which we've architected in a very different time. Now, we didn't architect this particular DLL at the time, when quad-core machines are available. So there's a lot more hardware capabilities that we have in machines today. So GDI has this behavior in a way that if there is one application called onto the GDI on a certain set of functions, another application will be blocked waiting for that first application to get out of the way, and it is a very, very high level lock in the operating system code. So it was a great difficult task of big difficulty for the team to get around this piece of code in the operating system, and we battled around for it the entire team for months. So what we have done finally with this particular thing is that we've refactored it. The problem is, if you were running on a quad-core or something along those lines, and one application goes in there and takes a page fault, that's it. The UI is logged, and for a period of time until that application gets out of there. So that page fault might be there for 400 milliseconds, or it might be there for a long period of time. So you can't afford to have that user interface lost. That's not one of the design constraints of Windows 7. So we've fixed that with a lot of hard work which was put into there. We've fixed that particular part now. And so this is the one of the key things. So what that means for most people is that the UI should not be blocked and hanging as much as it used to do earlier. So you get back to the user interface and get back to your desktop working in a much faster manner than what you could have done in the earlier versions of Windows. So some of the other things that we've done from the responsiveness perspective is the superfetch. Now, how many of you know about superfetch? Have you heard of superfetch earlier? Even those who have worked with this concept was there in Vista as well. Have you heard of it? Sorry, the poll is open now. All right. So many of you, while you have heard of it, some of you have heard of it, but you don't know what that particular feature does, and many of you have not heard of it. All right. So let's discuss about it. Superfetch is an intelligent prefetcher. Basically, its whole purpose and job in life is that if you've got a a disk medium. The job of the superfetch is to get the memory pages you're going to need in the memory before you need them. So that when you fire an application, basically it just faults in that page it wants to fault it, right? So it gets all those whatever pages you are going to need for a particular application. Its job is to pre-fetch those pages in the memory so that the application responsiveness is much better. So coming back to the presentation. So that's kind of what superfetch does in a very basic and simple way. Now with superfetch, we spend a lot of time in this release tuning the superfetch. Because it has been there since Vista also. So we used a lot of tracing, a lot of feedback to understand what was happening on these systems. So some of the things that we know is that some of you might have seen that when you're using Windows Vista, you started your machine, the disk doesn't stop. It keeps on working. The disk is not stopping because we are doing a lot of prefetching, a low priority work in the background. We don't do that anymore with Windows 10. So the machine quickly comes to a workable state very fast. The other thing that we did with superfetch and with the search indexer is that when we detect the fact that the user there is a user present, those services basically stop doing their job. They don't do anything in the background. So we only take advantage of the halted state before we fault in the particular service to do any more search indexing. So when you are working onto the system actively, the superfetch service in the background or the search indexer is not working. It's going to only do its job when you pause your program, when the system is idle, system is inactive. That is when it is going to do most of its job. So the whole idea is getting the resources as soon as possible, getting the machine ready as soon as possible, and using the resources to the user. So after some time, superfetch will fetch the pages you need into the memory and then move on, and you'll get benefit from superfetch ultimately. So the other thing superfetch does is that it turns itself off whenever it detects a fairly good SSD, the solid state disk. Now that is where your Windows Experience Index comes in. So you might have seen that if you go to your Windows systems properties, it gives you a value, a Windows Experience Index value that is basically a value that the lowest part of your operating system configuration gives you. Now, if you've got a very good hard disk, so the Windows Experience Index calculates that particular value when you install Windows on your machine. So if it calculates that you have a hard disk which is a very good hard disk and gives you a rating of about 6.5 or higher in the Windows Experience Index for the disk, it means that you've got a really good hard drive. So what it does is it then turns off the superfetch. Because if you have a really good hard drive, it means you can fetch your memory pages right there and then. You don't need to prefetch, right? If your hard disk is that good, you can fetch your pages as soon as you're going to need them. So there's no need for prefetch. So because prefetching pages into the memory, faulting pages, recording the changes, faulting them back into the memory during standby, and bringing them all up together when you're bringing your system back up, all that is a lot of processing, all that is a lot of job. Especially on systems where you're having a netbook these days with 1 GB of RAM and Intel Atom processor, it's actually a lot of overhead than the normal laptops or than the normal desktops. So if you're facing this is another hint. If you're facing long startup times, you can actually significantly save your boot time by turning off the superfetch service and the search indexer. If you really have a good hard disk, you can also do that at that point of time. So that will really improve the performance of your system also. Internet Explorer 8. So why we put in the Internet Explorer 8 is this is from a responsiveness perspective again, because we've learned that people keep the IE open pretty much all the time. One session on the couple of tabs on Windows Internet Explorer are almost open all the time. So what we've done with Internet Explorer is that with IE, it actually has a lot of improvements built into it from a performance perspective. Internet Explorer 8 is actually a loosely coupled process. Now, all the tabs in Internet Explorer, as you all know, are actually all these separate processes. So all the communication, the messaging between these processes, between these tabs is now asynchronous. So what does that mean? That means that Internet Explorer will be more responsive now. And the pre-parser, which is a little bit more intelligent now. So if you open up a page that contains the JScript or CSS, we will concurrently go off and get that content, and any other content which contains it as well. So your page does not hang, neither does it take a long time for you to open up that particular page, and the load time is pretty much faster. So the chart that you see here, on the left side you see IE7 and the right side you see IE8. Now we see some concurrency effect there to the processing of those particular scripts. So a lot of work went into the CPU savings and just optimizing the code, the pauses, runtime, manipulation engines. Now people comment these days, many a times that IE8 feels better, it's much more stable, it doesn't hang up, it feels better, it works faster than IE7. So these are all the reasons that have gone into it. So some of the other things that we've done here as well, and again this is very much dependent upon the content types. Those who run data centers, I know how you're going to feel about this, but IE used to have 2 concurrent connections to the host to pull down the content earlier. So that limit has been bumped up if you're running on a fast network. So we have up to now 6 open connections on one piece of content. So definitely the amount of time it takes us for a particular page content to load is going to be much faster now. So the faster is your internet connection, the faster is the speed of the broadband or the wide area network you're connected to, the speed with which your page is rendered onto the IE is going to be much faster. So if you look at this chart with IE7, it's time. Yes, from left to right, you see the amount of time it takes to render the same amount of content. IE7 was taking kind of 17 seconds for a page to load. Now this one page, before the user thinks, maybe, the page is done. So with IE8, we've done it in about 10 seconds or so, and that's a significant improvement. One of the other key scenarios that we've focused on quite heavy is that in a scenario where, let's say, you are on the airport, or you go to a coffee shop, you basically slept your machine at some point of time, and now you want to quickly make a check on your mail. So maybe you're in a coffee shop and you want to check your mail. So that's pretty cool in that scenario. You just open up, you resume your desktop, your laptop quickly, come out of standby as soon as you log in. You want the wireless network to be reconnected as soon as you log in, and you want your email to be connected as soon as possible too. We've done a lot of work in this space. Now the wireless LAN, the pop-up has got finer granularity now. We've tuned the time it takes looking for the network and reconnecting to the network. So earlier what it used to do was, whenever your system used to come up from standby and it used to try to reconnect to the wireless area network, every time it used to do that, it used to reconnect with the DHCP to attain a new leaf or a new IP address. That's not the case now. So with DHCP, we cached the addresses. Different users from different networks that you connected to have your machine has been connected to before, the user is cached. So earlier we used to do that every time the machine used to go off and come back on. It used to request for new addresses. So it still does that detection for kind of duplicate addresses only and not at other points of time. So reconnecting proxy connection also takes up to 15 seconds or so while the user is sitting and waiting for reconnection. And that's another piece of data that we've cached as a part of our actual network. Another thing that we encourage is to look into the Windows, into the Office Outlook 2007 Service Pack 2. So if you're network administrators, I strongly recommend that you look into the Service Pack 2 of Outlook 2007. because in it includes lots of changes that were made in this scenario of how Outlook reconnects to the Exchange server as soon as the internet connection is detected. Because generally there is a time gap between when your wireless LAN gets reconnected and when your Outlook gets connected back to the Exchange server. There is a time gap. With the Service Pack 2, we've done lots of improvements in Outlook, Outlook 2007 Service Pack 2 make sure that Outlook reconnects. So if you're running, it runs on WinHTTP, right? Now you quickly reconnect to the Exchange server while it is running WinHTTP, and it makes a lot of improvements, and the time gap is really reduced over there. So, of course, all these improvements in Outlook have already been built into the new Office 2010 that's coming up. But of course, if you're right now running on Office 2007, I strongly recommend that you download Outlook Service Pack 2 and deploy it in your network so as the users can take advantage of it. Now, ReadyBoost. So, sorry. I assume most of you know what ReadyBoost is. Now, ReadyBoost, as the name suggests, is a particular technology that we have. It has been there with Windows Vista also. Now, what it actually does is, if you've got a machine and if the machine is running high on its workload, it's running higher number of applications, much more memory-intensive applications than what you expected it to be, and you do not have that much amount of RAM available, and your machine is performing slow. ReadyBoost basically gives an extra memory cache so that you can keep going faster and the responsiveness is kept up. Now, once you're thinking of ReadyBoost, that means basically you can plug in a piece of flash memory through your USB memory stick, and you can enable it for speeding up your system so that it gives ready cache, ready memory available, and reading from flash memory is really fast. So it gives a ready boost to your system. Now, what's recommended over here, there is a piece of guidance over here. Now, once you're thinking of ReadyBoost, think of the size rather than the speed of the device. So don't think if you have, unlimited flash memory, you'll give it all to the ReadyBoost. That's not really going to, make a lot of difference. So there's a piece of guidance over here. So let's say you're running on 1 GB Atom PC. So typical netbooks that you're getting these days in the market, all are coming up with the Intel Atom processor, 1 GB of RAM. So you may want to increase it to 4 times with ReadyBoost on your machine. So that means you may think of putting 4 GB of your USB flash drive memory dedicated as a part of a ReadyBoost memory. So that's going to make a lot of difference onto that particular machine. But on a machine where you have 4 GB, RAM, you may want 2 times, in terms of the amount of flash memory you put on that machine. So if you have 4 GB RAM built into the system and you still want to give it a ReadyBoost, then what is recommended is that you have, 8 GB given to it max as a part of your ReadyBoost, as a part of the ready cache memory from the flash drive. That's going to give a good boost to your system. So what ReadyBoost does is that with increasing the number of ReadyBoost caches that are available, we've also allowed you to have bigger caches now. So you see that we're talking about 32 GB as being given to the amount of ReadyBoost cache that you can have on your PC now. So one more thing that we're looking here is at the processor speed and the processor capabilities. Now, if it's a low processor, it will automatically turn off the compression on the flash. So what we do is generally when we use the flash memory from the USB stick, the data that's written on memory pages, that are written onto the flash memory are normally in a compressed format. But compressing, writing the pages on that flash memory and then, getting them back, uncompressing them and making them available for reading, all that is a lot of job for the processor. And you can imagine that if you're running on a, Intel Atom processor on a network, all that is going to actually increase a lot of overhead on the system processor. So what it does is it automatically turns off the compression on the flash. So for example, on the Atom machines that you have, compression is turned off automatically because, There's a lot of overhead, processor overhead on the system, and that gives you an improved performance. So OEMs can also build. So these days OEMs are giving you machines which have got, ready boots built into it. So they've got flash memory built into the system, and if it scales up their business, that is kind of advertising they can do, and earn good amounts of money with those particular features. If it attracts more customers, they can do that. All right. So this, of course, this really matters in terms of how your system is performing. So what you see here is a chart. Now, what this chart is giving is basically something like 130 hard drives. Now, each of those bars that you're seeing is one single hard drive, right? Now, this behavior definitely has a major impact on your system responsiveness. High-speed disk systems really give you a good read performance onto the system, and your applications tend to work faster. Now, concerning the hard drives, what you see over here is with the typical solid state drives, the responsiveness of the system is really increased, and the amount of time it takes for the system to read the pages on the memory is very increased. Now, what you can have is you can actually run a Windows Experience Index check on your system by right-clicking your computer and going to Properties. Once you evaluate how your system is performing, it gives you a detailed report of what is the capability or what are the shortcomings on your system. So it will give you a value of how your disk is performing. So if it is performing really low, it will put that note up in your report saying that you have good capabilities on the processor, on the amount of RAM you have on the system, but the kind of hard disk that you are having is performing really low. So if your RPMs are going to be really high, it indicates that your system is performing low. So it is taking about 700 milliseconds for you to load a particular application, and you're seeing that spinning donut indefinitely. That means sometimes that your hard disk is performing, the read-write capability of your hard disk is very low, and that is the time when you can take a decision upon whether you want to consider changing the hard disk of your system, or considering changing the hardware configuration of the system. So we see over here a window. Now that's the report that's given to you by the Windows Experience Index, and it gives you caution over here saying that your disk might be performing low. So if you are actually going to change your hard disk, it might give you a good performance, read-write performance on your system. So that's one thing that you might consider while working with Windows 7. So although the built-in scenario with Windows 7 is that it gives you good read-write performance, good application, resuming and standby, but of course you have to make sure that the read-write capability of your system is really good. Memory. So finally, we talk about the memory over here and what we've done with Windows 7, all that we've been working about is we have been talking about and working on to get a very low memory imprint of the system. There's a lot of hard work that has been going in for it, and the entire goal of the Windows 7 development team, performance team, has been to improve the responsiveness and to minimize the kind of memory footprint that you have onto the system. Alright, so what are you seeing over here? In the blue is the task manager. What view does the task manager give you of the memory usage while the system is idle, right? And what the green bar gives you over here is what is the Windows 7 bar over here, what Windows 7 is basically using. So we've really reduced if you're running on a virtual system, same kind of investments have gone into the Windows Server 2008 R2 also. So if you're using the Windows Server 2008 R2, same kind of kernel mappings have been done in R2 server, and you will see a lot of memory, usage improvements in Windows Server 2008 R2 also. We've done over 500 memory reductions and enhancements in terms of saving the memory across the core Windows kernel. We've really worked on a lot of runtime components, WMI, XML, file system, shell support, terminal services in Windows Server, security components, networking, and we've made sure that all these components have as minimum of memory footprint as possible onto the particular system. But if you're working on a Windows Server R2 operating system, the memory imprint is going to be, the size also is going to be a lot smaller than what you've been experiencing with Windows Server 2003 R2. And if you're working in virtualization environment, it's a real boost to your boon to you as a part of virtualization, because low memory of the operating system that means that if the host operating system is occupying very low memory, that means you can host more and more virtual machines on that particular server, right? So you can pack up more virtual machines over there. So a whole bunch of cache memory on the system is available to your applications to run. So we need to know where is the Windows operating system. Now, what you see over here is a view of one set of, the same set of machine that we've been talking about. So the blue bar here gives us a task manager view. What the task manager tells of the memory usage while the system is idle. So here the kind of gray bar, light gray bar that you see is Windows 7. That is the memory reference set. So the memory reference set is a set of memory pages that the Windows operating system needs to have resident in the memory so that it is not paging. So the actual need of the Windows operating system is somewhere around 150 to 200 MB, and that's it. And when I'm talking of that 150 200 MB, memory usage of the core operating system, not the core operating, the full operating system. So I'm talking about that's what the kernel asks you for. And by the way, I'm talking of the ultimate SKU of the operating system, which is all the services running on it, all the built-in services running on it. But a caveat over here is that I'm not talking of a domain-connected machine, because when you connect your machine to the domain, you have a lot more services coming up. You have your domain policies, you have your firewall policies, you have your antivirus. Services running in, working on it in the background. So that adds up a lot of, memory usage onto your system. So when we're talking of a standalone machine which is not connected to the domain, the core usage of memory by the core Windows operating system kernel is as small as about 150 to 200 MB. And I believe that really surprises a lot of you to believing that Windows can have such a low memory input. All right. So we see over here the data, tells us that a lot of applications these days, we try to work with a lot of vendors and third-party softwares and application developers, so as to make sure that the applications that they develop for Windows are all Windows, WTTM version 1.1 compliant. Now, what that means is that generally what used to happen was that applications, when they got loaded, a copy of their page used to get loaded up into the memory, and a copy of each page of the application was also getting loaded up into the graphics driver system. So we did a lot of changes with that, and we made sure that with Windows 7 we don't have a copy of the application. If you have a copy of that application page in the memory, we don't need to have a copy of that application page in the graphics driver anymore. And that reduces a lot of memory involved in running that particular application, a lot of memory being used by the operating system in running the application, and it saves a lot of memory on my system. So we want to make sure that when you're installing the applications, even the third-party applications, we are talking with with those, we're talking with those vendors, most of the vendors that if you're working with ISVs and other partners, you want to make sure that those applications are WDDM, Windows Driver version 1.1 compliant, and that is the advantage that you get. You see the blue bar over here refers to Windows Vista SP1 applications, and you see that the green bar over here refers to Windows 7 WDDM version 1.1 compliant applications, and it gives you, out of 50, the amount of usage, the difference gives you, it gives you 4 bytes of difference into each particular memory page, and that saves a lot of memory onto the application. Of course, so we'll quickly cover this up. Here we have examples of process, heap growth over time. So the same workload, when you're comparing Windows Vista, we've put a lot of work into improving the heap usage of applications of Windows operating systems, and we've achieved a lot of improvement into it. So when we compare Windows 7 and Windows Vista, Windows 7 is much more resilient to process resources over time. So, and that is very important on lower end systems also. So the heap memory usage of the Windows operating system processes and applications comes out to be much lower over a period of time as the operating system is performing, and that is really good for the system. We have a whole bunch of services built into Windows 7 now that are not automatic start. So this is another new type of startup of services that we've introduced in Windows 7, and that is the trigger startup services. So trigger start services can be started, for example, when you plug in a Bluetooth device. So Bluetooth service is not running in the background all the time. So the moment it detects that a Bluetooth, device is plugged into the system, is attached to the system, the Bluetooth service comes up automatically and shuts down back when the device is disconnected. So similarly, the BitLocker service starts up only when there is a new drive, a new volume that comes up onto the system, and it prompts you to whether you want to enable it for BitLocker or not, and otherwise that particular service is off. So a number of triggers that can include, device plugging in, plugging out, IP address change. When the system joins the domain, then only certain particular services start up. And that's, a lot depends upon the application developers, the service developers also. So we are working with a lot of vendors, with a lot of application developers to make sure the kind of applications they are building, the kind of services they are building into those applications, we want to make sure that, they want to make sure that whether the service is really needed to start up at the start time, because, that's going to have a lot of impact on how much time your system takes up on startup. And as many as 38 services in Windows 7 have been changed to trigger start. So imagine how much of the service would, these services, how much of the memory these services were consuming before, when they were all, when the startup type was automatic. They all used to, take a long time to start up by the time the user is waiting to get to his desktop. And now all these services get only started only when a kind of event is triggered. So, of course, the benefits include the faster boot time, shutdown time, resuming time, time from standby and hibernation. So, multiple file operations that happen on this particular service, all of these particular services running, we save upon them. We save upon more than 50 MB of memory of allocation, 30,000 registry operations, and hundreds of threads which are being saved into the memory have been saved. And that, you can really see that kind of improvement that, we have customers who have actually, who had actually deferred some old configuration machines because Windows Vista was really high on demanding the kind of hardware usage, processor usage, memory usage. So they had deferred those machines. They have actually pulled those machines out, like Pentium 3 machines and other machines out, and have installed it with Windows 7. And they're so delighted to see that Windows 7 is really performing, as good as their Windows XP or better than that on those old machines. And you really see those kinds of improvements coming up when you install Windows 7 on your desktop. Of course, a lot of energy efficiency, the power consumption factor has been great in terms of, and now with the green IT thing coming up, we want to make sure that we have the lowest imprint on the energy that it consumes, the power that your system consumes, and we work upon it in a number of ways, in the way that it is much more effective. We work a lot on the background activity. So now the background processes are running only in idle state, and they stop working. And device power management, a lot of devices will consume a lot of power, and we made sure if there is a lot of background activity, we have worked upon these services, what keeps working in the background. So even if your system is idle, we see that there are many services, many applications that are still running that will prevent your processor from entering into an idle state, from entering into a low power state. And that is where we have worked with the application developers to make sure that these processors consume much less energy and much less power. Also, with the power policy, we used to have a balanced and a high performance state, and now we have about 11 different, 15 different kind of power plans, with which you can choose how your power consumption is affected onto your system. We even have now the dimming. It's by default around 2 minutes after your work of inactivity. If you're not working on your system, the light on your screen. You see, a lot of power, you would all agree, gets consumed in what we view. The monitor takes up a lot of power, onto the Windows operating system. A lot of energy efficiency goes into the monitor power. So we make sure that after a little bit of inactivity, while you are out to cafeteria, etc., after 2 minutes, the dimming of the monitor actually saves a lot of power. And we even have a utility called the Power CSG. So you can just, use this command. I'll just share my command line with you. So here, I can just, give the command and you see that Power CSG, it gives me a number of switches which can give me output in whatever way I specify. So I can say Power CSG / energy. I can give a command like Power CSG / energy, and it will run. Let me just see if I have. So what it is going to do is, it's going to enable the power tracing for about 60 seconds or so, observe the system behavior, and while all this time it is working out upon what might be the ways in which there are various components in the operating system, various other applications which might be consuming higher power than what they actually need. So this is going to run a trace for 60 seconds and observe the system behavior and then produce a report as to what might be consuming more power in my system than what actually is required. And it produces an HTML output which you can view in the browser, and make sure that you're running the right power plan. You can easily also see what is the current power plan that you're running on. So I can, click upon my, I'll share my desktop with you. So you see over here, I can click upon this and I can see what is my current power plan, right? I can see more power options over here. Right? I can change the plan settings. I can change what my system should do. I can choose to when to turn off the display. I can even, increase and decrease the brightness of my system. For example, I can go to adjust screen brightness, and you see over here, I can increase and decrease the brightness. Earlier, you see, we could do this only with the monitor hardware switches that used to allow us to reduce and increase the amount of dimming and amount of brightness onto the screen, and we now have a software switch to do that. Right? So I can go to. So I'll share this with you. So this is the kind of report it presents to you. It gives you the errors. The program has made request to automatically enter sleep, low power mode. So all that you see is in red, or more, I can say it's in pink, right? Now what it says is, this is my computer name, configuration, it gives you all those roles, etc. Now the warning, now here, the CPU processor utilization is high, the average processor utilization during the trace was high, system will consume less power and the average processing utilization is very low. So review the processor utilization for individual processors to determine which applications and services contribute to the total processing utilization. Of course, that must be the same because I'm running about 10 applications here with live beating. And it gives you a number of warnings. It gives you the processor ID that might be consuming a lot of power, and it gives you, what are the current processes and how much of the power consumption is there with each and every process. And it gives you a good hint on how you can optimize the usage, how you can, configure those particular DLLs so as they consume less power. So it gives you the number of the active power plan you have, its GUID. You can change with power CFG. So it gives me the currently active scheme is this GUID. And if you want to list what are the current schemes available on your system, aliases. So what I can do is I can give a switch called aliases over here, and it gives me the various power schemes available and their GUID. So you can give sub-sleep, hibernate idle, video dim level, sub-task, all these various console lock, etc. And if you want to change your active power scheme, either you can do it through the GUI, or you can use the power CFG command to, set the active scheme to a particular GUID. So you can say set active value index, and you can give the set active index, and you can give the GUID of the scheme that you want to set as a current power scheme right now.
Please pardon the interruption. Your conference contains less than 3 participants at this time. If you would like to continue, press star 1 now, or the conference will be terminated.
Presentation. Just all right. And we worked a lot on the various activities that consume a lot of power consumption. The DVD spinning used to be, consuming a lot of power, so we made sure that DVD spinning is now optimized to consume to save a lot of power, so that you can view a full movie now on battery while you're traveling or you're catching a flight. And you can do that now with Windows 7. Yes, that's possible. So we've gathered a lot of data and feedback, and that is what we've primarily been working on. So here, as a part of our beta testing and as a part of RC testing, we used to have values, and whenever, specifically during search, we used to keep, whenever a user searches program or a particular utility, it used to return us a particular value saying how often, a particular value is searched, or how the user performs a search, and what does the user prefer. How much time does it take for the user to open up a particular item, a particular application. It used to just return a value saying that this is the kind of searching, or this is the habit in which, and this is the amount of time it takes. For example, the start menu typically takes upon 15 milliseconds. As it is taking a lot of time, it gives feedback upon what can be done to the system to make the responsiveness faster. And that we get a lot of data upon it, and that helps us actually develop, invest in the technologies that could help us improve the responsiveness of the system. So you see the difference over here. Now with the initial builds of the beta, you see the green bar. Now the green bar actually tells you, that how much time the start menu used to take up while the system was up and running. And now when you see the, near RC build, you see that the green bar has gone really, really less. And that's a good indicator. That's an indicator that Windows, is performing better and better, and the start menu takes much less time than it used to in the operating system. And this is an example of a way in which the Windows operating system is really being working. Some of the other tools that can help you measure the performance of your system. So Windows Performance Toolkit is available, Performance Analyzer is available as a tool for you to download. You can go to the Windows Engineering blog. You can go to the performance. You can search for Windows Performance Analyzer tool, and that's the official tool that you can download and test your system. So I'll give you a view of how this tool works. So if you have run the performance monitor on your system and you run a trace, it gives you an ETL file, right? You can open up that particular ETL file in the Windows Performance Toolkit, and when you open the Performance Analyzer, I'll just share the Performance Analyzer with you. You can open the Performance Analyzer. This is an ETL file that I have saved as a part of my performance monitor. So it opens up this particular file, and here you see I have, it gives me reads and write, and it gives me a lot of data on how the processes, the various checkpoints that were performed onto the system, provider IDs, etc. And gives you a scale of how, over a period of 60 seconds, how was the particular performance of the system, how was the processor performance, this performance, IO counts, and I can actually, mark an area over here and load symbols onto it, and I can see the IO counts, the reads, writes, etc. So you can see interactively, I can work with this particular graph and see a particular process. Now you have a complete manual on how to work with the performance analyzer and how to make full use of it to analyze and test the performance of your system. So if you are an administrator and you really want to run a test over a period of time to see if all the configuration of your system, the hardware configuration tools on your system are performing to the optimum level, this is an efficient and probably the best tool available that you can use as a part of your system. So it tells you, the various processes, files, etc., and their disk counts, read-write counts. This is one of the ways in which you can give the memory offset. It works with flush time, right side. Of course, you also have another, besides the help on the performance analyzer, you even have manual to get quickly started with the performance analyzer and how to use the performance analyzer to test the performance of your system. So you can download this particular tool that's available on Microsoft Downloads. Some of the other references that you can get over here, you can go to the Windows 7 engineering blog, and that gives you a real insight, and you can even source feedback and have discussions on what went into the improvement, and if you feel good about it, you can give the feedback to the actual Windows 7 engineering team. And we have a number of white papers available on Windows 7 performance, performance values like on-off solutions, performance testing, memory considerations that were there, how mobile battery life has really been improved with the mobile solutions, mobile broadband technology that we use with Windows 7, how wireless effectiveness has been improved, in Windows 7. So these are all the inputs that you can get from these links over here. So I will now leave the session for questions and answers, and I will try to answer most of those questions on the audio, and you can use the Q&A tab on your live meeting console to ask me questions over here. All right. The type of disk support in Windows 7, of course, by default, as usual, is basic disk, and you can convert them to dynamic disk. Of course, if there are multiple LAN cards and they're connected to multiple networks, the network and sharing center shows that you're connected to multiple networks, and you can even have multiple kinds of profiles and locations set up for your multiple networks. All right. So I don't see many other questions right now. So there is one question I would like to ask you now, is that sorry, that's not the poll. I've asked that question earlier. No, just a minute. So this is the poll I want to give to all of you and ask whether if you have used Windows 7, do you think it really performs better than the earlier operating systems Microsoft had produced? All right. So you can see the result by your own is 90% of you say that yes, it performs better than what earlier operating systems of Microsoft has performed. So I think the purpose of the session gets solved over here, and I would like really for to all of you, those who have not installed Windows 7 yet, Although the downloads are disabled for RC now, but if you've downloaded Windows 7 RC or any of your friends have done it, please take a copy of the Windows 7 RC from them. Try it before it gets publicly released for the public on October 22nd this particular year. So all the best to all of you for trying Windows 7. Hope you enjoyed the session and you will come back to the rest of the sessions in this series also. So thank you very much. And I'm signing off from this particular meeting right now.